class. I'm here to talk about problem 80. The reason is because we're talking about proportion, and I really want to go over it. If I have time, I'm also going to go over problem 98 and problem 114. However, I do want to jump into chapter 10. I have put in here all the variables and the formulas that you're going to need for this problem, as you're going to be working with proportion. And right here, when you read the problem, you're going to determine that you're going to be working with a normal distribution. I'm going to explain that. Therefore, I put the formula here to calculate your test statistic and your p-value. Okay, and also I worked on the problem before, so I could have put a graph together. And as you can see, we're going to be working with a two-tailed test right here. Okay, so and another important thing, we're gonna need n, we're gonna need x, we're gonna need what they call the p hat, or the simple proportion. Okay, and then your q is what they call the failures, and then your and then right here you're gonna have 1 minus your success, which is determines the percentage of failures. So let's go over the problem, so all this should make a little more sense. So your statistics instructor, not me, claims that 60% of the students who take her elementary statistics class go through life feeling more enriched. Okay, so the statistics instructor claims that 60%, we're talking about proportion, correct? Well, here you could understand different ways. Your book understand as we're talking about a equals or greater than, which would have a one tail. However, I would say that here it claims that 60%. So she's saying that is equals to 60%. Therefore, I am gonna go with that my proportion. Remember, percentage is 60%. Therefore, if my null hypothesis, my proportion is equals to 60, for my alternative hypothesis, which you should be used to it by now, it's going to be different than, correct, 60. Um, Another thing you can, I took it from right here. So if your no is equals, then your alternative is going to be different. And then remember the little hint that I gave you, that I hope that was helpful. On your alternative hypothesis, you have the little two bars. So we're going to say that's a two-tailed test. And let's continue. For some reason that she cannot quite figure out, most people don't believe her. You decided to check this on your own. So you randomly survey 64 people of her past elementary statistics students, and you find out that 34 feel more enriched as a result of her class. Now, what do you think? You have surveyed 64 and you figure that 34 actually agree with her. We want to know the simple proportion of these values, which is also called your p hat. So you're gonna do your 34 divided by 64, and you learn that your simple proportion is 53%. 53% actually agree with the elementary uh, statistics instructor. She says 60%. So now we're gonna see, is any of this any true? Well, we also gonna need what we call the number of failures. So we know the number of failures is equals 1 minus what we determine as the number of success. In this case, she's saying 60% to be successful. So your failures is the remaining 40%. By stating your null hypothesis, remember I'm going by Appendix E from your book. So I'm answering A, null hypothesis. B, your alternative hypothesis. I really try to get rid of this noise on the errors, and I was not successful, and I apologize for that. Okay, here you go. And then now we're gonna define in words what either my mean or my simple proportion means. So right here we define it, it's gonna be a proportion problem. So we're gonna put that the proportion is equals to the proportion of students who feel more enriched as a result of taking elementary statistics. Okay, I guess we can, yeah, that's good enough. And then right here, stated distribution to use for the test. You're working with a sample, the total sample 64, and you have sample 34 out of 64. You're still working with a normal distribution because you're talking about uh, a sample size higher than 30. A sample size higher than 30, remember? So we're going to be using the normal distribution. And then in this case, for a single proportion. What is my p-value? In order to calculate my p-value, I'm going to need this formula right here. So let's go and try to replace all the values. And instead of putting the referring to the cells, I'm going to put the numbers to see if it makes more sense to you. So I have said that my p hat right here, my simple proportion is 53 minus my actual proportion 60 divided by the square root of, again, my proportion, which is 60, times 1 minus my proportion, which we know is the failure, which is 40, but here we're doing the full formula, divided by my sample size of 64. And you should find something around minus 1.14. Since this is a two tails, just look as 1.14. If you would have put more, if you put more digits here, and you have, let me make it this bigger, see if I can make it this bigger for you. Okay, and you have actually refer, you see how it's gonna vary a little bit. You have referred to the cells. You'll notice a small difference. I just want to show you, because if you do calculate and you say, hold on a second, she got 114 or she got 112, but I got different. Why? And that's why I'm gonna replace here, because in this case Excel is using every single digit that is over here on this division. There we go. See now how we see it as 1.12 instead of 14. You would be correct either way. I would not deduct points if I would see that you got the right formula, but instead of using all digits, you have just kept it at two digits. That's fine. So um, we have figured that our t, actually this should be over here, right? Okay, so we have figured that our z-score is 1.12. Z-score is minus 1.12. We're gonna go to our z-table over here, and we're gonna look for minus 1.12. In your case, if you would have calculated as minus 1.14, then it would also be correct, because the difference is gonna actually here, the more precise you are, the better to make a decision, to not be biased, but like again, depends really how you calculate this. So minus 1.1, and then let's look for the 2 to make 1.12. Remember, you're not adding then, you're combining then. Here you go. It's 0.1314. So your percentage, which the Z table provides you the percentages right here, and the Z scores over here. The T table is different. Okay, you have the percentages on the top, and then you have the T scores in the table. Okay, so right here, 0.1314. So your p-value, 0.1314. However, I mentioned this is a two tails, so we want to know everything below um, below the mean, and we want to know everything above the mean, but just for these little portions between minus 1.12 and plus 1.12. Therefore, I'm multiplying, again, I'm multiplying my percentage that I have found by 2. And now I'm saying that this portion right here plus this portion right here, it's about 26% over here. 26%. See how the digits have changed very little over here? 1.12 and then 26%. 1, 2, 3. Let me put one more digit in here and see what happened. Well, I got that right. And then over here, it's telling you it's about 2616. And then I have calculated 2628. Very close. Okay. So let's go to the alpha. Well, right here, you're not being provided the alpha at all, correct? So again, anytime a hypothesis testing does not provide you the alpha, you automatically use 0.05 as a default. Okay, so your alpha, we're going to use a 0.05. Your decision, well, let me make my decision. Here I have 5% and here I have a 26%. Therefore, my alpha is smaller than my p-value, correct? Let's just put 2 digits. So if your alpha it's smaller than your p-value, what do? You do not reject your null hypothesis, right? And now I can maybe, I don't think it's gonna fit, but the reason is because the p-value is greater than 0.05. Conclusion? Well, the professor says 60% of them they feel more enriched. The value is greater than the alpha. Conclusion, if we're not rejecting the null hypothesis, and the null hypothesis that 60% of the students feel more enriched, so we're going to conclude that there is insufficient evidence to conclude that less than 60% of her students feel more enriched. That means we cannot conclude the alternative. We have to accept, fail to reject, do not reject the null hypothesis. Okay, now to construct our confidence interval, I have put the formula right here. So I don't know if I can make this, if it's going to be too small for you to see it, because I want you to see all the values. We know a 90 for a normal distribution at a 95, at a Z table at a 95%. By now you should know by heart is a 1.96. I'm just following this portion right here, Z times this portion right here, which actually, you know what? Let me go ahead and crop in here because I want you just to calculate Let me see. Better. Here we go. I'll make it bigger for you. So 1.96 times the square root of my p hat, my simple proportion over here, times 1 minus, excuse me, my p hat divided by my sample size. And then you're going to find your error bound proportion, 0.12. Therefore, for your true mean, which in this case we are considering as your simple proportion. So your true mean, it's going to be this value. For the lower bound, let me write here. For the lower bound, we're going to do this true proportion right here. What's it mean? True proportion minus your error bound for proportion, and then for the upper bound, you're going to find your true proportion plus this value right here. I'm just gonna leave it 3 digits actually. So this and this one right here. Okay. So I'm gonna conclude that my confidence interval is gonna be between about 41% and 65%. And then you would be done with problem 80. I hope this helps. Again, if I have time, I'm going to go over problem 98 and 114. However, I really want to start addressing chapter 10